Hi, everybody. Welcome to Code Vipassana Season 9. Today, we are starting with the first code lab of this season. This season revolves around agentic applications and its use cases, and today we're looking at one such application. Today, we're going to build a contextual yoga poses recommender app with Firestore, vector search, and Gemini 2.0. This code lab features multiple technologies, but don't worry if you're new to Google Cloud or Code Vipassana. We've made sure that the code labs not only teach us how to implement the technologies, but they also educate us about the technologies. Firestore is a NoSQL database. Vector search helps us generate embeddings, store them, and perform similarity searches. And Gemini 2.0 is our model by Google that we're going to use. On a high level, what we'll be building is we'll create a Firestore collection and load yoga documents. Then using the CRUD framework, which is create, read, update, and delete, we will store and do operations with the documents within Firestore. Then we will generate yoga poses descriptions with Gemini 2.0 Flash. We will enable the Firebase vector search with Firestore integration. We will generate embeddings from yoga description. And finally, we can also perform similarity search for search user text. Feel free to browse through the entire code lab in the overview section to know more about this code lab, and let's get started. To start with this code lab, you need to go to console.cloud.google.com, where you will be greeted with a dashboard. Make sure that you have a project selected. You can check it in the top right corner where the arrows are, or you can check it there. Also, if you have multiple projects in your Google Cloud account, you can click here to select whichever project you like. Coming back to the code lab, we can now start implementing commands inside a Cloud Shell terminal. A Cloud Shell terminal is just like a normal terminal on our system, but it is connected to our Google Cloud, so we can execute commands directly from there. Let's go to the Google Cloud platform. Let's click on Activate Cloud Shell. Here, instead of performing all the commands here, we'd like to open it in a new tab so that we can keep our Google Cloud dashboard separate and our terminal separate. You can authorize this here, but close it and then go to the other tab that you just opened. Authorize it, let it happen. Then you can go open the editor. You can close the previous terminal. The editor on the Google Cloud platform is just like an IDE, for example, VS Code, to help you with familiarity. To open the terminal, we can click on the hamburger menu and click on New Terminal. From now on, we can access all our terminal commands from here, execute them, and also use the Explorer as a way to access our files. Let's go back to the code lab to see what we need to do next. The first command we need to execute is gcloud auth list. That will basically show us if our terminal is connected to our Google account. Copy paste, press enter. It says active. It shows my email ID. That means we're good to go, up and running. Then we can go for the next command, which is gcloud config list project. This will basically show you if your terminal is connected to a project. If it says unset, that means your terminal is not connected to a project yet. But don't worry, the next command is just for that. The next command is gcloud config set project and your project ID. Remember, I told you your project ID is the most important thing. Here, you have to replace the entire your project ID part with your project ID. How you can find your project ID if you don't remember it is you can go to the dashboard screen that we previously left open and you can type in your project ID from there. I'll just show you in a second how to do that. This is my project ID. This is how you can find yours. You can click on the projects under the ID column, that is your project ID, or you can also copy it from here. Press enter and it will set your project as the project ID for that terminal. Now that we're done setting the project for our terminal, we need to enable some APIs that are required for this project, which are Google Cloud technologies. So instead of copy and pasting this command on the terminal, what we can do is we can use the hyperlink here, open it, and then enable it with the click of one button while ensuring that there are no errors. This is usually the safe way to do it, but you can choose to do it either way. We'll click on enable and let it do its job. Now that you can see the button is grayed out and we can no longer click it, that means all the APIs have been enabled and we're good to go. Finally, now that we have the APIs enabled, you can check them in the notification section and we can go back to our code lab to proceed with the further steps. Let's click on next. And this step is the database setup step, where we set up our Firestore database of NoSQL documents. We need to create the Firestore database. So we open this in a new tab, copy the link, paste it in a new tab. Once we open this link, we need to follow the steps given in the code lab to make our database and make sure to populate it with the documents. Let's go back to the code lab. We have some steps here that we are supposed to choose the file store in native mode. We're supposed to select a location. We're supposed to select a location for our file store, and we need to create the database where we leave it as default. Very, very, very important. We're supposed to choose the test version of the security rules so that the data is accessible to you. Let's go and do these steps. Let's click on create database. Let it load. We'll select the native mode as, then we'll click on continue. We'll let this be default. We'll let the other settings be multi-region, that's okay. And in the security rules, as said, very, very important, we'll select test rules. Once that's done, we can click on create database. The database will be created in 10 to 15 seconds. After that, we will be greeted with a screen that is something like this. Once the screen is here, we can use multiple ways to populate the database. Let's go back to the code lab. As per the code lab, we don't have to do this step where we can create a new collection. How we can do that is I'll just show you, but let's not do it right now. We can click on start collection, give our collection any name and click on save, but we'll not do that right now. Let's follow the code lab. We will be using the Firestore REST API to help with our NoSQL documents and also data retrieval, storage, and search. We will be using Spring Boot along with it. So firstly, let's clone the GitHub repository, which helps us get all the code for this application from GitHub to our Google Cloud Platform. Go back to the tab where you have the Cloud Shell running, paste the command, hit enter. You can see on your left, you have the Firestore pose recommender inside your directory. What you can do is you can change the directory and press CD and enter the directory. Firstly, go back to the home, check where you are, go back to what your Google account's name is, CD your Google account name. We can again use the command cd, which is change directory into a Firestore post recommender and enter that directory to carry out the other functions and other steps. From this point onward, it's going to be very simple. So let's just follow the steps and hopefully you don't encounter any issues. What we need to do next is we need to change the code of some files, but it's going to be very basic. Inside every file, there will be a section where your project ID will be there in double arrows. We need to replace that with our actual project ID inside of these four files. Let's go ahead and do that. Let's go back to our editor, open up the folder, follow the path. You can see it's under src, main, Java, and let's go under the first file, which is called generate image sample. You can see that's the file we're looking for. Press Command F to get up the window, copy and paste what we need to replace. So your project ID is the instance we need to replace. Let's press that. Then what we need to replace it with is our project ID. As you remember, my project ID is test-code-vipassana. So I will be using that. You can include your project ID. Press the icon on the right. It will replace all instances of that project ID with your project ID. We can do this with all other files we have. The next file we have is generateembeddings.java. Same exact process, Command F. You need to replace your project ID with the project ID that you have. You can see that here in this file, there are two instances of project ID. We can replace both of them together by using this simple arrow. Let's go ahead, enter our project ID, and just press that icon. Boom. We've replaced both our project IDs with our project ID. Let's go ahead and do it for the next file, postcontroller.java, Command F. Here there are four instances where we need to replace things. This process makes it a lot simpler. We need to make sure of one more thing, that the database name here is default. We can make sure that it is default by going back to the terminal and going to the file, typing database, and you can see wherever it is database, it takes the path as default. There are only two instances of database here, and in both the cases, it is taking default as the path name. So we're good to go. Next, again in the same file, we need to replace the API key here with the API key of Gemini. So you can see if we press Command F here, put your API key, there are two instances where we need to put an API key. Please note that an API key is unique to every user, so we will need to take it for ourselves. What we can do is find out our API key and find the one we want to replace it with. Let's go ahead and get our key. We can click on the hyperlink for AI Studio, which will take us to Google AI Studio in a new tab. Here we can simply click on Create an API key, where it will give us an option to copy our API key. I click on Create API key. It is generating one for me. Once it's done, I can click on Copy, go back to my editor in Google Cloud Console, and I can press it in there and replace it with that instance. Our API's keys are set inside of the project, and we're good to go with this step. This was the last thing we needed to do in this step, so let's move on. Now, let's preview if our application is working. A simple way to do that is using the web preview option in Google Cloud. We can copy the following Java code inside a terminal to build the application and use Google Cloud's web preview feature to view our application. Thus, another way you can do this is you can deploy the app in Cloud Run, which basically means that you can provide a public link to anybody and they can access your application. We can do this as a side quest at the end of this code lab or some other time. For now, let's use the web preview to run this application. We can copy the code, go back to our terminal, paste it in the terminal, press enter, and it will build our application. The build doesn't take that much time to complete. It's doing the steps that it needs to do, and the final step of building, and it's done. We can go and copy the next step, which is deploying it on localhost, which is using Spring Boot. We're running the application. We copy, we paste, enter. Again, merely a 15-20 second pause, and we can deploy the application. As you can see, Tomcat has started on the port 8080. The project ID is test code Vipassana. So what we can do is we can go on the top right and click on the icon which says Web Preview. We can click on it and it will show us a preview of how this website looks like. This is how it looks like. We can go browse in. This is a simple interface using Java. For now, we can't search anything because we've not added the data yet, but that is going to be our next step. In the data ingestion step, what we can do is we can get the code from the GitHub repo, which we've already cloned. So let's find the file data.json inside our editor. Let's go navigate inside Firestore, and there is data.json. We need to find data.json. We found data.json, and as you can see, these are the documents that we can use to store inside Firestore for vector search, for embeddings, for everything. Again, let's use the same process. Copy your project ID, paste it inside. Fine, put your actual project ID in and replace all instances. Once that's done, you can see it in front of your eyes. Let's move on to the next step. How we can import this into Google Cloud by using Firestore Studio is open this link in a new tab, go to Firestore Studios, and then we can put it in one shot or do it manually one at a time. Let's see the way where we can do it one shot. We can start a collection, name it poses, as said in the code lab, and we can add a first dummy document. We can name it anything. Let's just click on save. It auto takes a document, and then we can go back to our terminal. We can use this command inside of the terminal to create a new bucket inside of Google Cloud with the data that we have. Let's copy paste the command into the terminal and replace your project ID with our actual project ID. You can see me doing it. As soon as I'm done, let's press enter. It will say creating the bucket. It will be done within 2 seconds. Then we go back to the code lab, take a look at the next command. Again, the same process. We copy the command, paste the command, and replace your project ID with our project ID, and then we press enter. Once that's done, it will copy all the data into the Google Cloud bucket, and we can finally go to the import export section of Firestore Studio, and we can import all the data that we had in our data.json file inside of our Firestore databases. Let's go to the Firestore Studio. We can click on the import export section. Since we want to import the data, let's click on import. Once we click on import, we can browse for a file where we can import the data from. You can see there is a list of buckets. There's the bucket that we created with our project ID on it. Let's go there and browse the file that is called yoga poses overall export metadata. Let's find that file inside of the bucket. Let's navigate. There's that file. Let's click on that file, select it, and click on import. Once that import is successful, you can go back to Firestore Studio and you can see all the yoga poses have been imported inside of our collection poses. The first document which was there, you can delete it since it was just a test document. It does not matter, but you can do it if you want. I'll delete the document. You can click on delete document to delete it, delete, and that's it. Now that we have all our documents inside Firestore, we can start with the next step. As you can see, the documents have various formats, various fields, a lot of description, a lot of metadata, and that's how data is stored in a NoSQL database in Firestore. What you can see is that we can also create a document manually like this, enter any name for the document ID, add any kinds of fields, keep it varying from one document to another, and that's how a NoSQL database and Firestore helps us in creating apps in Google Cloud. Let's move on to the next step in this database, which is vector search. For vector search, we'll need to install an extension using Firebase. This extension is very important as it will help us generate and manage embeddings for Firestore. Once we click on the link, we can click on install in Firebase. We can get started with the Firebase project if you don't have one. When you go, do not click on enter your project name. You have to go and select add Firebase to a Google Cloud project because your billing is enabled on that project and you have your project there. Once you click on this, you can select your Google Cloud project. My Google Cloud project is test code Vipassana. I select that. I click on continue. I click on continue. You can enable Google Analytics if you want, or if you want, you can not enable it. As I said, I'm leaving it checked as default. Click on continue. You can select that account as default. And finally, add Firebase. Give it some time to initialize Firebase inside your Google Cloud. And once it's done, we can move on to the next step. As you can see, our Firebase project is ready. We can click on continue. It will automatically redirect us to install the extension, and it will tell us that we need to configure some things. All the configurations are given here in Google Cloud. All we need to do is follow the steps. Let's go ahead and do that. This is the page we'll be greeted with. We can click on next. We can review the APIs enabled if needed. If there are some APIs that have not been enabled, we can click on enable and enable them. If you get any error of any kind, do remember to start them in test mode. Click on next, click on done. It will enable the API. If you get any error, simply reload the page. The error should be resolved. As you can see, I just refresh the page. Again, go through the same steps, click on next, review the APIs. This time they've all been enabled, so click on next. Again, click on next. All of that is by default. Here is where we need to do some things. In the LLM as specified in the code lab, we need to select Vertex AI and not Gemini. Let's go ahead and do that. LLM has to be Vertex AI. We select the LLM to be Vertex AI. Moving on, we can leave these fields to be blank. We can move to the collection path where it has to be poses as we saw in the code lab. The next field is default query limit, which is 3 as shown. The distance measure is cosine. The input field is not input, it is posture. So let's select that and paste it here. Again, the output field name is embedding, so that's okay. The status field name is status. Again, that's okay. The next field is embed existing documents. Yes, because we've already added documents. We want to embed existing documents, and we also want to update the existing embeddings if we have any. So we will select that too. The cloud function can be situated at US Central 1, which is the default location for anything we do in this project. We do not check the enable and events box since we don't require it. And we can finally click on install extension. Once we click on install extension, it will take about 3 to 7 minutes to install the extension, build a lot of things. As you can see, the process has already started. Let's wait for it to install the extension. As you can see, we've encountered an error installing this extension. This is a very common error. If you encounter it, if you don't, well and good. You can skip a little bit ahead in the video, but I'll make this short. So how we can fix this error is you can uninstall the extension. It will take a very short time to uninstall the extension. Then you need to refresh the page. You need to close any tabs that you have, reopen all the tabs, and then finally you can try reinstalling the extension again by using the same steps as we did before, configuring the extension using the link, and you will be good to go. As you can see, if I'm reinstalling the extension right now, hopefully I should be getting a successful extension initialization. The installation is almost done. You can see that You can see that now the installation was successful and the extension is installed. It shows the status is processing. That means that it was installed. And now we can move on to the next and second last step of the code lab. Step 7 of this code lab is all about Gemini 2.0 Flash. It shows us various things, for example, how we're doing the vector search, how we're generating the text to speech, and every other call, how Gemini 2.0 now can give us access to all other APIs in just one Gemini API call, and how we ground it with Google search. You can go through it if you like, but for now, we'd like to move to the next step. Finally, we can run our application by building it again like we did last time and running it on the local port. So what we can do is we can copy paste the command mbn package in the terminal. Make sure that you're inside the fire post recommender directory and you're also inside the project so that you don't encounter any errors. Once that's done, you can see that the build has started. The build will take some time as usual, a minute or two. Once this build is successful, we will run it and we will deploy it on our local host, that is port 8080, and then we will be able to access the entire app along with all of its features. As you can see, it's about 73% done. It's conducting some unit tests. It's almost all done, all successful, and now we can finally move on to the next step, which is running it using Spring Boot. Let's go back to the code lab and copy the second command, which is mbn spring-boot :run. This will get our application to run on the local port. Okay, now our application is successfully deployed. You can see that the Tomcat has started on the port 8080. The default project ID is test-code Vipassana. Let's preview it on port 8080. We can see that it's loading and boom, yoga post recommender. Let's search post by name. Let's put the first post, which was Halasana. If I click on submit, I can very well access the record as it was given to it by our data.json file. Like that, we can run our own query, we can create our own post, we can do a lot of things using this page. That was it for this code lab, and we will see you again the next time. If you have any doubts, please feel free to reach out to our team on Discord, and we hope to see you again soon. Thank you.